Hi guys, this is Assignment Expert and today we prepared the following task for you. A 40-gram mass is attached to the vertically hanging spring and extended by 0.4 centimeters. Let's find the spring constant, also the extension of the spring with the weight 100 grams and the oscillation period with 100 grams. And also let's find the spring constant and the oscillation period when we divide our spring into 3 equal parts and hang 100 grams on one of them. So let's begin. The first two tasks. To find out what are the spring constant and the extension, we need to recall the Hooke's law. It goes like this: F equals Kx, where F is the force applied to the spring, K is the spring constant, and X is the extension. On the other hand, F equals mg, where m is the mass and g is the free fall acceleration. From here we can derive the spring constant K. K equals mg over x. In our case, this is 0.04 times 9.8 divided by 0.004. And this gives us 98 newtons per meter. So here we found the spring constant. From the same formula we can derive the extension under the law at 100 grams. So X equals mg over K. This time m is 100 grams, so we have 0.1 times 9.8 divided by the spring constant 98. And this gives us 0.01 meters. So this is 1 centimeter. Now our next task is to find the oscillation period with the law at 100 grams. For that we have the period formula. T equals 2 pi times the square root of m over k. And this is 2 pi times the square root of m 0.1 divided by 98. And this gives us 0.2 seconds. So our first three tasks are complete. Here we have the spring constant, the extension under 100 grams, and the oscillation period with 100 grams. Let's proceed. Alright guys, now our last task. Let's assume that for the whole spring F, the force applied to it, is equal to K big times X big. So this is the spring constant for the whole spring and the extension of the whole spring under law at 100 grams. And then we divide our spring into 3 equal parts. The force applied to one of them will be the same, but the formula will be K small times X small. So this is the spring constant and the extension for 1/3 of the spring. Knowing that we divided spring into 3 equal parts means that X small equals X big divided by 3. So now we can rewrite this as K big times X big equals K small times X big divided by 3. And we can cancel out X big, and from here we derive K small as K big times 3. So 3K big. And this gives us 3 times 98 and equals 294 newtons per meter. So here we found the spring constant from 1/3 of the spring. Now let's find the oscillation period for 1/3 of the spring with the law at 100 grams. We will use the same period formula, 2 pi times the square root of m over k. But this time we have 2 pi times the square root of 0.1 divided by 294. And this gives us 0.11 seconds. So that's it, guys. All our tasks are complete. See you next time.